Hello everyone, welcome to all of you in my lecture of heat transfer. So in the previous lecture of lecture 1 of evaporation, that is on the evaporator, already I have discussed about the material balance and energy balance for the single effect evaporator, and I have discussed about the capacity of evaporator. So here in this lecture I will be discussing about capacity and steam economy of the evaporator and the effect of the boiling point elevation on the economy and capacity of the single effect evaporator. So let's try to understand the concept. So yeah, again I'm going to discuss about the capacity and we'll come to the economy here. So first I'm discussing about the capacity. It's just a recap of previous lecture that the capacity of evaporator that is defined as V and that is equals to kg of water evaporated uh, per hour from the evaporator, right? So generally what we see here from a single effect evaporator, here generally we try to feed uh, supply feed. Here it is coming as a V and here it will be L, and the basic material balance, the here the stream will be going having a stream flow rate is S and here it is lambda S. So here V is our capacity, right? So this was the capacity of the evaporator. Now coming to the steam economy of the evaporator. Steam economy, sometimes it will be called as only economy of the evaporator, right? So don't get confused. So this is defined as kg of water evaporated per kg of steam feed, right? So here, my dear student, you can see that here steam feed is S and kg of water evaporated is V. So can I write here that is our steam economy that is equals to, my dear student, V upon S, right? So this is as simple as that. That is the steam economy. So here it will be also in kg per hour. If I am assuming the unit, so it will be also in kg per hour. So the unit of steam economy is unitless, right? So it will be unitless, right? Hope uh, you all get to understand that the concept regarding the steam economy and the steam evaporator capacity. Now, my dear student, one more thing that is very important, that sometimes what happens here, that you all have studied about some properties of solution, right? So here if it is our feed and here feed is going here in the form of vapor, that is, and it is liquid, and here it is steam is coming, right, having latent heat of vaporization lambda s, right? So here the temperature is T. So sometimes what happens, my dear student, this is here our solution will be there, right? Here our solution will be there, that is being evaporated, or that is we are trying to concentrate that solution, right? So sometimes what happens, due to some impurity, the boiling point of solution get increased, right? So there is very important property of solution, that is elevation in boiling point, right? Elevation in boiling point, and this is a colligative property that we all used to study in class 12 solution topics in physical chemistry. So that depends upon, that is depends upon number of moles of solute. depends upon number of moles of solute. So I'm not going to why it's happening and all. So just try to understand due to some reason, due to presence of impurities and all, the boiling point of the solution will get increased. So I am assuming initial boiling point of solution was T, and after elevation, the boiling point will becomes equals to T dash, right? So I am trying to let you understand one thing. Initially, what we have derived S into lambda S, that is equals to my constant UA T of steam minus T here steam temperature, and here that T is solution temperature, because solution is at boiling point, so you can call it as a boiling point of the solution also, right? So now, so initially it was our T, right? So it is delta T, that is the driving force for the evaporation. That is the driving force for the evaporation, right? So it's very important parameter. Now, my dear student, after elevation of boiling point, after elevation of boiling point, what will you say? That T is getting increased and it is getting T dash, right? Where T dash is greater than T. T dash is greater than T, right? So, if we say, if we call it now S into lambda S, that is equals to UA, and now that is TS minus T dash, right? So that is equals to Q. Now try to understand one thing. Since T dash is greater than T, sorry, since T dash is greater than T, so can I say TS minus T dash that will be less than TS minus T? Agree or not? All are agree about this? That will be correct. Now, if Ts minus T dash is less than Ts minus T, then after elevation of boiling point, what we can say, the driving force will get decreased. And if driving force is getting decreased for same value of Q, if we are keeping Q same, I mean, if you want to supply same amount of S into lambda S, that is Q. Okay, for same value of Q, what we can say, if U, if initially UA1 Ts minus T, that has to be equals to UA2 Ts minus T dash, since Ts minus T is greater than Ts minus T dash, my dear friend, Ts minus T is greater than T minus T dash, and U is equals to U. So what can I say? So A2 should be greater than 1. Means more area of evaporator will require for the same amount of water to get evaporated for a particular single impact evaporator if there is increase in boiling point. So that one of the important finding is here. So boiling point elevation, here I can write, so we can write boiling point elevation requires more area for the same effect, right? So it's very important finding. In one mark question you can get it, right? So that was like that. So wait one second, I'm facing some difficulties over here. So yeah, so I think hope up to this point the thing is very clear to all of you. So with increase in boiling point, more area will require for the evaporation, right? So now next thing is that one more thing that I want to convey here. So that S into lambda S that I have derived, that is equals to UA Ts minus T, that is equals to V into lambda V plus F Cp, and that was T minus Tf, right? That was T minus Tf. Now I understand, if I am considering case first, if T is less than Tf, if that solution temperature is less than Tf, so it will be called as a loading term, because we'll have to supply more and more amount of heat to the evaporator for getting evaporated. Now, if T equals to Tf, so what will happen? F Cp T minus Tf, that will be equals to 0. So here it will be equals to flash evaporation, that you'll have to keep in mind. As soon as you will feed the I mean, you will put feed into the evaporator, it will get evaporated soon, right? And if T is greater than Tf, if T is greater than Tf, sorry, here I have done one mistake. Oh, let me one thing. Here, yeah. So here, if T is less than Tf, since the elevate, I mean the solution's boiling point is less than feed temperature, so as soon as you will feed into the evaporator, feed will get evaporated. So it is called as flash evaporation. And if solution boiling point is greater than Tf, then it will be a loading. It is called as the loading for the evaporator. Means you'll have to, I mean, make T feed to T, okay, by supplying heat from the stream, and after that the solution will get evaporated, right? That like that, okay. So here up to here I have discussed about the effect of boiling point elevation and as well as the this leading and loading term, right? So now I am going to discuss some topics regarding multiple effect evaporator, right? So try to understand multiple effect evaporator now. Here in this lecture, I am giving just only flavor of that multiple effect evaporator. In the subsequent lecture, I will be discussing about the whole concept of the multiple effect evaporator. So here, in multiple effect evaporator, what happens? What will you see? Just try to understand. Here you will see there will be multiple evaporator will be connected in series, right? So here I am just taking three evaporator and it will be connected in series, right? So here you will be supplying feed, and here there will be a steam jacket, right? So steam will be coming like that. Now, so here what you will see, here the vapor will be coming here, and here this vapor will go to this effect. This vapor will go to this effect for heating, and it will be coming like that, right? And the bottom of this, that again will have to concentrated liquid will go as a feed for this effect evaporator, right? Now again the top of this evaporator will come and will go for the heating for the feed of this effective third effect, and the bottom of the second effect will work as a feed for the third effect, right? and finally you will be getting final product from here, and here final product here. So here it will be final product, right? So here you are supplying feed in multiple effective vector. What you can see one thing here, we are supplying heat in only single effect, in first effect. If I am assuming this is first effect, if this is second effect, and if it is third effect, so it's very important here only we are supplying steam for the first effect, and the water vapor or the vapor produced in first effect will work as the stream for the second effect, and the bottom of this first effect will work as a feed for the second effect here, and the top that the water vapor coming from second effect will work as a stream for the third effect, and the bottom of the second effect will be working as feed of third effect, and finally you will be getting the final product over here, and that will be the concentrated final product, right? So this is called as a forward feed effect. Forward feed, this is known as forward or feed forward evaporator. Feed forward evaporator. Why? Because uh, here you can see the steam and feed is going through the evaporator in the same direction. Okay, so both feed and steam is going in same direction through the evaporator. So whenever the feed and steam is going in the same direction in the evaporator, that evaporator is called as the feed forward evaporator. Why? Because both the feed and steam is going in the same direction, and we are getting final product, concentrated product from the third evaporator, right? So I hope I have cleared all your concept to this point. So in the next lecture, I will be discussing about the backward effect feed effect evaporator, and why multiple if we use multiple effect evaporator in the industry. Okay. So thank you and all the best.